one is parabolas, and we are going to use this reference sheet on every test or quiz about conics, including the final exam. So you need to become familiar with it and how to use it. The parabolas are, I hope you can find, they're above the ellipses on that side. Okay. These are not parabolas on the other side. Those at the top are hyperbolas. But it should say the word parabolas. Then you're on the right side. All right. So you have that reference sheet, and we're going to refer to that. I want to start, we did this yesterday though, right? We talked about that there's different ways you can cut a conic, and a parabola is formed by cutting parallel to the slant height. The definition of a parabola, the definition of a circle yesterday was all points equidistant from a given point in a plane. Okay, does that make sense? Are all the points 5 inches away from some center point? Okay, the locus of points is a fancy way of saying all the points that satisfy something. The locus of points for a parabola is all the points equidistant from both a single point called the focus and a specific line called the directrix. So the definition of a parabola is you have some point and some line. This is new vocabulary that you need to be able to understand, okay? A focus is a point, focal point. Good? Directrix, on the other hand, is a line. The directrix is a line. Now, if I said I want all the points the same distance from this point as they are from this line, well, there's an obvious one. Does that seem okay? It's the same distance from F as it is from the line. That's actually the vertex of this parabola. But over here somewhere, let me see if I can estimate. There is a point that is approximately the same distance from that line as it is from this. Does that look close to the same distance? Yeah, it looks like I can't draw a straight line. Okay. Over here somewhere, maybe, there's another point that is the same distance here as it is here. There's another point maybe way out here somewhere that is the same distance here as it is, if that was the perpendicular, down to that directrix, okay? All of those points that are the same distance away will make a parabola, which mine is really bad, okay? It goes through the vertex. Yes, the parabola goes through a vertex. We've had that idea before. The focus point is inside the parabola. Does everybody see that? If you erase all this gobbledygook, the focus is somewhere inside the curvature, okay? And the directrix is a line that the parabola bends away from. So this one would be called facing up, or when you get to calculus, it's called concave up. Everybody remember that word? Okay. Inside of that concavity is the focus, and the directrix is a line outside of there from which it bends away. Yes. It could be further away. The further, I'm going to show you a little interactive thing that talks about that, okay? Give me 1 second. I want to go back real quick. Do you remember what an axis of symmetry is as well? Goes right through the middle of the parabola. Have we ever done parabolas that open sideways? No. So we're going to do parabolas today that open sideways. They're going to have X and Y switched around. All right. Here's the interactive thing I was talking about. These are the kinds of parabolas we've been doing in the past where they open up and down. Everybody watching? Look what happens as I move the focus point closer to the vertex. What happens? It gets narrower, okay? Do you also see that this distance right here is staying the same as this distance? That's what I just talked about, okay? The same is true if I were to take this whole line and move it, okay? The closer together the focus and the directrix are, the narrower the parabola is. That seem okay? All right, I just want to show you one more thing. Dun, da, da. Okay, here's what happens. I don't know if you can see this. It says y plus 3 quantity squared equals 4 times 3 times the quantity x minus 1. The vertex is going to be h and k, but the y is squared, not the x this time. I don't know. Maybe I can't move that. Okay. But again, it's going to open sideways. Does anybody know what you think would make it open to the left? Yeah, we're going to have a negative in here. Okay. And that's going to make it open to the left. All right. So what made it really narrow? Yeah, if the focus and directrix and vertex are all really close together. Okay. That was just a quick view of that. I spent a little time researching. Just wanted to give you a quick view. Parabolas have features they use in the real world. This is the interesting part. Light rays that hit will be reflected at a parallel. So this is my horrible, but if you have a headlight on your car, they put the actual light bulb at the focal point, because then every bit of light that is sent out hits the parabola shape and it reflects parallel to this axis of symmetry. So it reflects straight out. Okay, the same is true. It talks about here about sound waves for a radio. It talks about some parabolic satellite dish. Let me just show you this, and then we're going to go on with the lesson. But okay, parabola. Where do you think that radio receiver right there is located? At the focus. Yes. So there's that. There's a headlight. This is a parabolic shape. Okay. When you throw a basketball towards the hoop, if you throw it up high enough, it will come down in a parabolic shape. The water from a fountain makes parabolas. Okay. There was a really cool discussion at the bottom here. I think, maybe it was a different site, about whether the arch in St. Louis is actually a parabola, and they had a big fancy explanation showing that it's not a parabola actually. Has another name, and I had never heard of it before. All right, we are going on to talk about the forms. Does this look like what we did first semester? Okay. The vertex was at HK. Today the vertex is going to be at HK. Okay, that part's not changing. A had to do with the stretch and the reflection. If A was a big number, it actually went up faster, so it was skinnier. Okay. If A was negative, it opened down, that kind of thing. Well, we're going to have a different relationship for A today. We're going to talk about P instead. And I need you to understand what P is. Let me see if I have a good place to draw this. Not really. P is the distance from the focus to the vertex. That's P. And the distance from the vertex to the directrix is going to also be exactly P then. Guys, I cannot stress enough that you need to understand what P is. The letter P stands for, okay, this P right in here stands for the distance from the vertex to the parabola and, I'm sorry, from the vertex to the focus and the focus to the directrix. Here it is. Da, da, da. This is in your notes. Everybody see it at the top of your notes? P is the distance from the vertex to the focus or the vertex to the directrix. It's the same distance. All right. We learned vertex form, the one I just wrote, and you could change this to a 1 over 4P instead of an A. Notice, please, that the 4p is in the denominator. It's not 1/4 p. Does everybody get it? The 4 and the p are in the denominator. All right, if I rearrange this form, I would have y minus k equals 1/4p x minus h squared. Then if I wanted to get rid of this 4p, I'd multiply it over here. And this is the form that's on the top of your sheets. Look at the top of your sheet. The very top. It says x minus h quantity squared equals 4p, everybody see it? Times the quantity y minus k. Then there are two pictures underneath. How do you know if it's the one on the left or the one on the right? Underneath it says, on the left, p is greater than 0. See it right there? Right here. On the right, it says p is less than 0. Now, so p can be positive or negative, so is it really a distance? The absolute value of p would be the distance, okay? I'm calling it the distance, but it can be negative. All right. Then when we go to this format, this is new. What do you notice changes? Guys, what's in here being squared is the y, not the x. Okay, what's being squared is the y. That's what tells us it opens left or right, is if the squared quantity is the y. And then again, if p is greater than 0, it opens to the right. Does that make sense? If p is less than 0, it opens to the left. Negative, going to the left. All right, you get to use this sheet on everything, and it tells you the actual recipe to find all of this business right down here. So I'm going to start by explaining this one conceptually, and then we'll talk about the recipe if you just want to use the recipe. All right, I'm going to write the formula underneath. X minus h quantity squared equals 4p times y minus k. Why did I pick that formula? Why didn't I do y minus k quantity? Because this was an x that was being squared, so I just wrote the one underneath that matches. That makes sense? All right, so what can you tell me h is? H is 3. K is, be careful, -4. And in here we have 4p equals 12, so p equals 3. Okay, if I didn't have a graph, I would say my vertex is at 3, -4, h and k. I'd go over 3, down 4, dot. Then I would say p is +3, so it's opening up, and the vertex is the focus is exactly 3 units above the focus. The vertex, let me try that again. The focus is 3 units above the vertex, if I get my vocabulary right. And the directrix, the line, is 3 units below the vertex. So then I could have figured out if I went up 3 from here, I would be at 3, -1. This line is 3 down from here, which would be at -7. It's a horizontal line, so it's y equals -7. If I had used the sheet instead, let's do it on the next one rather than waste time. Let's try this one using the sheet, using the recipe. Okay, what am I going to write underneath here? You have this one. Y minus k squared equals 4p x minus h. It wants the vertex, the focus, the axis of symmetry, which I forgot to talk about on the last one, and the directrix. How many of those are points and how many are lines? These are points and these two are lines, so they need equations like x equals or y equals, okay? The vertex is HK. Can anybody tell me what H and K are from up here? H is 3, K is -1. Everybody good with that? Opposite. So HK is 3, -1. Right there. That's the vertex. So the parabola goes through that point, okay? The focus, well, let's see if we can figure it out conceptually, and then we'll use the formula. Right here, 4p equals 8, so p is 2. Now, is this one opening up, down, left, or right if it has a y that's squared? We're used to x squareds when we did up and down, right? A y squared means left or right, and a positive 2 means right. So this is going to open to the right. So 2 units to the right of that is going to be our focus. But let's use the recipe. What does the recipe say on your sheet? For a focus, it says underneath the one that has y first, focus is h plus p comma k. Is that what it says? What are h and p? There's a 3 and there's a 2, so we'd get 5, and k stays -1. Is that where I put it, guys? 5, -1? Okay, so you could have done it by thinking about the concept and drawing it on the graph paper, or you could have just used the recipe. All right, the directrix is going to be 2 units back this way, and it's going to be up and down because the parabola is opening to the right. Anybody know the equation? Well, don't tell me the equation. Let's go back over here and check for the directrix. What is the formula for directrix on your sheet when it's a sideways parabola? H minus p. So it's x equals, what's h again? 3 minus p, which is 2. So we get x equals 1. Is that the equation of that line we just drew? Crossing the x-axis at 1. Yes, Caitlin. Okay. The axis of symmetry, guys, we did axis of symmetry at the beginning of the year. It's the line that splits the parabola in half. It goes right through the vertex. And the equation of our sheet is y equals k. Y equals k. K is what? -1. So it would be this line. Really not too worried about the axis of symmetry. I don't think I put it on the quizzes. All right. This is the tricky part. I know it opens to the right, but I have to try to figure out a point. Okay? Everybody please pay attention closely. When you want to find how wide or narrow this is, on this problem, could I have just typed this in my calculator if I wanted to get the y by itself? I could have, right? It would have been a pain in the neck to move it all around, though. This one, I can't get the y by itself unless I do a square root. It's going to be a hot mess. So what I want to do is pick a point, at least 1 unit off the vertex. Now, you're going to want to pick whichever one is squared to put it in here. So the y value down here was -1. So let's just put in 0. That's 1 unit off the vertex, right? No? Yes? I'm going to put in a 0 because it's 1 unit away. If I put in a 0, I get 0 plus 1 quantity squared equals 8x minus 3. Okay, what's 0 plus 1? 1 squared is 1. So I have 1 equals 8 times x minus 3. If I divide by 8, because I don't really want to distribute, okay, then I'm supposed to add 3 over to this side. So I get 3 1/8. So if I went to 3 1/8, didn't come out nice at all, right? Then the y would be 0. So 3 1/8. Well, that doesn't help a whole lot. But is this going sideways very fast? No. We could find another point, but it's going to be pretty darn flat. Okay. If you want me to do one more, if I went to like y equals 3 up here, and I put it in, I'd have 3 plus 1 is 4. 4 squared is 16. Divided by 8 would be 2, plus 3 would be 5. So it would be at 1, 2, 3, 4, 5, and 4. Boy, I'm good. I couldn't get that accurate again if I tried. Mine went right through 5, 4. But that's the shape it's making, okay? That's the hardest part, honestly, is deciding how wide or narrow it is. All right, Which way is this one going? Okay, talk me through this super fast. X minus h quantity squared equals 4p times y minus 1. What can you tell me? H is -2. K is, this is supposed to be y minus k. Okay, so k is 1. 4p is equal to 4, so that just makes p 1. I was like, is he just being funny? 4p equals 4, so p is just 1. All right, so which set of recipes am I looking for? Guys, this is all new. Please be awake. Which set of recipes am I looking for? The ones on the left under the up down, or the ones on the right under the sideways? The left. So it says vertex is HK. It says focus is H comma K plus P. And we put those numbers in real fast. What would you get? -2 comma 1 plus 1 would be 2. It says the axis of symmetry is x equals h. What's h? -2. The directrix is y equals k minus p. What's k minus p? Y equals 0. All right, so if I plot the points, now be careful, this graph paper is counting by 2. So left 2 and up 1 is the vertex. Left 2 and up 2 is the focus. So which way is this parabola opening? Up and down, and it's opening up, right? Because the focus is inside the parabola. The axis of symmetry, x equals -2, would be up and down through the middle. And the directrix is y equals 0, which is actually the x-axis. So it goes through this vertex, right in the middle there, and it opens up and down. Okay, what's the squared quantity? The x. So I need to pick an x number. What do you want to pick? You put x equals 0, so we're going to figure out the y-intercept by putting in a 0. 0 plus 2 squared equals 4 times y minus 1. Okay, what happens? 0 plus 2, 2 squared is 4. What are we going to do then? Divide by this 4 because I'm too lazy to distribute it. And then add the 1. So I got 2 for y, when x was 0. Put in a 0. So 0, 2 is right here according to this graph paper. It's symmetric, so it would be doing the same thing on the other side. I'm not going to be super worried about accuracy. And this graph paper is hard to tell because it's counting by different numbers, by 2s. All right. I'm not going to take time to necessarily do all of these, but just get me started for number 3. It's opening sideways. Which way? Left or right? Okay, here is 4p. If that is positive, it's opening to the right. If it's negative, it's opening to the left, okay? So it's going to look like this. Let's write the equation down, and I'm not going to take time to graph it, but let's figure out what all the quantities are. How's that sound? Whoa, where did that 4 come from? Where did any of that come from? It's supposed to be 4p times x minus h. Okay, better. What's h? Bailey, what's h? Good job. K. Lindsay, what's k? Good job. 4p is equal to what quantity? Maddie, can you tell me? The 4p is equal to, so if we just solve that, we'll have p equals, careful. Anybody help her? What are we dividing by? Yeah, we're dividing by the 4, so we get 1/2. That's all right. All right, so vertex. Vertex is easy. Yeah, it's just HK. But everything from that, we need to be following recipes, kind of, right? Because it's going to be half a unit away. If I'm doing this conceptually, whoa, what does that say? 6-3 is right up here, and I'm supposed to go half a unit inside of it. I hate this graph paper. Can you even graph a half a unit when it's counting by 2s? Yeah, it's like nowhere. So in here somewhere is a focus point, and back here somewhere is going to be the directrix. I don't even care about graphing this one. Let's find what the equation would say, though. Opening sideways, it says h plus p comma k would be the focus. Somebody got a calculator? What's 6 plus 1/2? You can use 6.5, but they're going to give you things like a 12th eventually. So it'd be better if you just gave me an exact answer, please. It would be 13/2 if you did a math enter. But yeah, in terms of graphing it, you'd want to know that it's 6.5. All right, the directrix, I'm not going to worry about the axis because I didn't put on the quiz. The directrix is at x equals h minus p, which is a half unit back this way. So it would be x equals 6 minus 1/2, which would be 5.5 or 11/2. Okay, I can't even graph that on here because it's so tiny. Do you want me to practice that find a point one more time, though? Because that's the hardest part. You don't want to know. Pick a number for y. It's a little bit off of -3 here, the 3 for the y value. Like maybe 2 units away, 5? Can we pick 5? Okay, I'm going to put a 5 in for y. So it'll say 5 minus 3 is 2 squared equals 2x minus 6, okay? So this is 4. Now what happens? Divide by 2, add 6, and we get 8. What did I put in again? I put in a 5, right? So 8, 5 would be a point on here. Ugh, still ridiculously close, right? Oh my goodness. Make sure you're going through the vertex, not the focus. It's so close I can't even tell what I'm going through, but yeah. All right. What's wrong with this one? Something's very wrong. There is a fraction. Is it in the right form? What's supposed to happen? When I have an x minus h, I'm supposed to have a 4p over here. How can I get rid of a negative 1/12? Multiply by the reciprocal, which would be negative 12. Over here it'll go away, so it's going to show up in there. So it's going to be x minus 3 squared equals 12, negative 12, just kidding, times y minus 6. Which way is that one going to open? Down. The x is squared, so it opens up or down, and this is negative. P would be negative 3. K would be 6, and H would be 3. I'm going to skip that one. Are you okay? Really, the trick to that one was just rearranging it, okay? We're going to practice writing equations. To write the equation of a parabola, you're going to have to work some of these recipes backwards. So this one, conceptually, they tell us the focus is at negative, oh, I hate this graph paper. I'm just going to do it down here. 1, 2, 3, 4, 1, 2, 3. Negative 4, negative 3 is the focus, and the vertex is at positive 1, negative 3. That's a long ways. How far apart are those? From negative 4 to positive 1 is not 3. It's 5, right? Okay. But if my parabola has a vertex over here, it's opening this way, so P is actually going to be -5. All right, but we can find that without ever graphing it if we want. But conceptually, we just figured out P is -5. And they gave us the vertex, so did they give us H and K? Okay, the vertex just gives us H and K. I want to talk about how to find that P value using the recipe. For a sideways parabola, what is the recipe for focus? H plus P, comma, K. All right, as soon as they gave us the vertex, did everybody okay that we knew what H and K were? Okay. So H is 1 and K is -3. And somehow that focus point became what, guys, right here? -4, -3. Anybody see what I can do to solve that now? Well, this was right. This is just -3. But can I find P by setting that equal to that? So 1 plus P somehow became a -4 in the focus point. So that makes P. So without ever drawing a picture, I could have figured it out algebraically using the recipe. All right, now let's put it in the equation. For a sideways parabola, the equation is y minus k squared equals 4p x minus h. So plug the numbers in. Somebody? Y minus, what's h? Or k, sorry. -3, so it'll be y plus 3. Quantity squared equals 4 times p. 4 times -5 is -20. I'm not even sure I heard a single -20. Heard a lot of other stuff. And then x minus h would be x minus 1, yes? Okay. Break out what they want. So for the next one, do you want me to start with the recipe instead of conceptually? If this is the focus and this is the vertex, what are H and K? Yeah, this is H and K, right? So H is 2 and K is 5. Now, you might be able to figure out by looking at this whether it's going to open up, down, left, right. Which one of the choices has the same K for the focus and the vertex? Focus, vertex. This K value stayed the same. Do you see that? It has to be sideways. I would have never done that. I would have done a tiny little sketch. I would have said, okay, let's see, -1, 5, +2, 5. This is the vertex, so it's going this way. I would have just sketched it and realized which way it was going. All right, so it's going left. So what do you know about the focus? What's the formula? H plus P, comma, K. Okay, and what is that equal to for this particular one? 2, 5. Well, what else do we know? We know that H is 2. Yeah, this is not going well. We didn't give me the right focus. This is the vertex. Like, it can't be 0. What did we do wrong? The vertex, this is focus. The focal point is H plus P, comma, K. So the focal point is -1, 5. The H is 2. And the K is 5. So who can tell me what P has to be? This has to equal this. So 2 plus p equals -1. We subtract 2, we get -3. Does the negative make it open to the left? Could anybody have figured out that the distance from there to there was a -3, maybe? Okay, so let's write the equation. What's the recipe? Sideways, y minus k. Oh, my y is kind of sideways even. Equals 4p x minus h. Diego, can you put some numbers in? What's k? K is just 5, right? So it's going to be -5. 4p. Okay, everybody, this is where we ran out of steam last time. 4 times -3. Woo, good job. Okay, x minus h would be x minus 2. That's it. Okay, if we had graphed it, again, the vertex was at 2, +2, 5. The focus was all the way over here at -1, 5. So it's opening this way. Just to practice it, what's the number I could put in here? I'm going to go kind of big because this is big. It goes towards the focus, yes. So it should be opening to the left. Okay. Oh, sorry. I usually don't. So, you want to try -4? Let's see where it is down at -4. Okay. So if we put y equals -4 in, somebody said, what's -4 minus 5? -9 squared. 81. Okay, this will be interesting. I wanted to pick a number far away from 5 up here. So he suggested -4 because it's at the bottom of our graph paper. I don't know if it's even going to fit, but that's okay. So we put a -4 in here for the y, trying to find a point to tell me how wide it is. Okay. Somebody do 81 divided by -12. Type it in your calculator. -6.75. And that's x minus 2. So add 2 to that and you get, okay. So -4.75 would be over here and down -4. So there's the width. I just did that because I know everybody struggles with finding that point to show the width. Okay. We want to do one where they give us the directrix. Would you like to do number 8 or number 7? We only have time for one. 7? No? Let's do 7. I don't know. You want to do 8 at 0.5? Okay. Maybe we should figure out which way it opens. I don't know. If this, guys, if this has a vertex at 5, 3, and the equation is y equals 6 for the directrix, this is the vertex, and that's the directrix. So which way is this opening? Somewhere in here is a focus, right? It's opening down. I don't care what it looks like. I'm trying to write the equation anyway, so it's probably not accurate. So what can you tell me right now? H, K, H equals 5, K equals 3. Okay, when it's opening down, what is the equation for the directrix? It's opening down. The equation is y equals k minus p. Well, anybody help me find p? What's y? The directrix is 6. When k is So can we figure out what P is? We just plugged in numbers. It said Y equals 6 when K equals 3. If I subtract 3 right here, and then I change the sign or divide by -1, did that work? Do you remember what this was? This was up over 5 and up 3, and this line was up at 6. Is that a distance of 3? Okay, and it was opening down. That's why it turned out negative. All right, I think we can write the equation. General form for a opening down is, who can fill in a number? X minus 5, 4P, Y minus K, which is, yes, no, can you fill in those blanks? Are you confused? Who has a question? All right, I'm going to stop the recording and then I'm going to go over